Hi students, hope you all are well. In the last session we have already discussed that what is wind energy, different types of wind energy, how wind turbines work, calculation of power in the wind, power coefficient, what may be the maximum value of CP or power coefficient, calculation of forces on the blades and thrust on turbines, different factors affecting the distribution of wind energy on the surface of the earth. Suppose the pressure gradient force, Coriolis force, centripetal acceleration, frictional force, etc. Now, today we will learn somewhat more on wind energy. Let's start today's session. Today we will begin with the discussion on types of generators used with the wind turbines for producing electricity. There are mainly 4 types of wind turbine generators or WTGs which can be considered for the various wind turbine systems. Those are: number 1, direct current or DC generators; number 2, alternating current or AC, synchronous generators. These are synchronous generators. Number 3, AC asynchronous generators, and last but not the least, switch end reluctance generators. Each of these generators can be run at fixed or variable speed. Due to the dynamic nature of wind power, it is ideal to operate the WTGs at variable speed. Operating a generator at variable speed reduces the physical stress on the turbine blades and drive, and which improve the aerodynamic system efficiency and torque transient behaviors. Let us now discuss on DC generator. A DC wind generator system has a wind turbine, a DC generator, an insulated gate bipolar transistor or IGBT inverter, a transformer, a controller, and a power grid. For shunt-wound DC generators, the field current increases with operational speed, whereas the wind turbine drive torque determines the actual speed of the wind turbine. Electricity is extracted through brushes as AC power, which in turn converted into DC output. These generators need regular maintenance and are relatively costly because of using commutators and brushes. Using WTGs are unusual in the wind turbine applications except in the situations of low power demand. Next, let us discuss on AC synchronous generator. AC synchronous wind turbine generator can take constant or DC excitations from either permanent magnets or electromagnets. This is why they both are called permanent magnet synchronous generators or PMSGs and electrically excited synchronous generators or EESGs. When the wind turbine drives the rotor, 3-phase power is produced in the stator windings that are connected to the grid via transformers and power converters. In case of fixed speed synchronous generators, the rotor speed needs to be at exactly the synchronous speed, or else synchronization will be lost. When using fixed speed synchronous generators, random fluctuations of wind speed and periodic disturbances happen due to the tower shading effects. Moreover, synchronous WTGs tend to have a low damping effect so that they do not allow drivetrain transients to be absorbed electrically. When synchronous WTGs are integrated into the power grid. Synchronizing their frequency with the grid requires a delicate operation. In addition, these generators are more complex, costly, and prone to failure compared to induction generators. Now is the time to talk about AC asynchronous generators. When the traditional way of power generation uses synchronous generators, modern wind power systems use induction machines extensively in the wind turbine applications. The induction generators are classified into two types. Firstly, the fixed speed induction generator, that is FSIGs, with squirrel cage rotors, and doubly fed induction generators or DFIGs with wound rotors. Generally, induction generators are simple, reliable, inexpensive, and well designed. These generators have a high degree of damping and can absorb rotor speed fluctuations and drivetrain transients. In the case of fixed speed induction generators, the stator is connected to the grid through a transformer and the rotor is connected to the wind turbine through a gearbox. These generators were normally operated at 1500 RPM for the 50 Hz utility grid along with 3-stage gearbox. Squirrel cage induction generators SCIGs can be used in variable speed wind turbines as in controlling synchronous machines. In such cases, the output voltage, however, cannot be controlled and the external supply of the reactive power is required. It means fixed speed induction generators have restrictions when it comes to operating only within a narrow range of discrete